Okay, we have previously worked on solving a system of equations in two variables using elimination. All the examples we have done up to this point were pretty much set up nicely for us. Not only were most of them already in standard form, but also they were set up so that we could skip step 2. We never really had to multiply through, because if we skip straight ahead to step 3, which was adding the equations together, one of the variables was going to set up to be eliminated. So today we're going to look at some other cases for what could happen if we're solving a system by elimination. A couple of different things that could happen either in your work or in the final answer that you have. A couple of special cases in the final answer. So if we look at this one, we see that both equations are in standard form. But if we were to add together both of these equations right now, the 3x added to the negative x is going to give us 2x, so that does not eliminate x. And 6y added to 3y is going to give us a 9y. So neither the x got eliminated nor the y got eliminated. So what we're going to do is we're going to do that step 2, which is to multiply one or both of the equations. Remember, we want one of the variables at least to have opposites. So in this case, either one of them is not too bad, but I'm going to look and say, okay, here I have a 3x. So ideally, I would love to have a negative 3x here so that the x's could get eliminated. Okay, so what I'm going to do is I'm going to multiply through this equation. The multiplication property of equality says I can pick any number at all that I want to and multiply both sides of the equation by that number. In this case, in order for this understood negative 1 to become the negative 3 that I want, I'm going to multiply by 3. And as long as I multiply all parts of this equation by 3, it will be fine. Okay, so just for convenience sake to keep everything together, I'm going to copy the first equation back down, and then I'm going to multiply every term in the second equation by 3. That'll give me a negative 3x plus 9y equals 6. Okay, from this point on, it's just like what we were doing yesterday. The x's get eliminated, the y's give me 15y equals 30. And then I can divide both sides by 15 and get that y equals 2. Okay, and again, remember, in a minute when I reveal my answer, that should be half of my answer. I know that y is 2. All right, I'm going to copy down either one of the original equations, or technically I have a third option here because I have this one here where I multiplied everything by 3, this bottom equation, so that's another option. It really makes no difference. I think I'm going to choose to use negative x plus 3y equals 2, except now that I know that y is 2, so negative x plus 6 equals 2. I'm going to subtract 6 from both sides and get negative x equals negative 4. So x equals 4. There's the other half of my answer. Okay, my answer is the order pair 4, 2. If I were to graph them, this is the point where they would cross. This is the one and only ordered pair that I could substitute into both of the original equations and have it be true in both of them. Okay? All right, let's skip down to number 2. Okay, both equations are in standard form. Okay, as of right now, nothing is going to be eliminated, so I'm going to have to do step 2, which is multiply through. Now again, this one happens to be one where one variable is not necessarily that much easier than the first one. Okay, I could multiply the top equation by negative 5, so this would be a negative 5x, but I think just to be different this time, I'm going to eliminate y. So if this is 4y, I would ideally want that to be a negative 4y. So I'm going to multiply that y by negative 4, and as long as I do it to both sides, it's okay. Oops, not ready to add yet. So negative 4x minus 4y equals positive 12, and 5x plus 4y equals negative 10. Now I'm ready to add them together because these make 0 and that variable will be eliminated. Okay, so that'll give me x equals 2. That's half of my answer. Okay, this one seems pretty straightforward. X plus y equals negative 3. 2 plus y equals negative 3. Subtract 2 So y equals -5. All right, let's check and see if I did that right. Okay, all right. There will be occasions that will come up where you're actually going to have to multiply the top equation by one number and the bottom equation by a completely different number. We'll look at some of those in just a minute. All right, so now we're going to look and see what happens if in the course of trying to eliminate one variable you accidentally, although it's not really an accident, but eventually both of them get eliminated, okay? So both equations are in standard form. I have opposites, so the x's will be eliminated, but as it turns out, not only will these make 0, but these will also make 0. So on this side, I have nothing but 0, and over here I have 23. So the fact that I have no variable to solve for tells me this is one of the special cases. Remember when I did this with graphing, okay, I could either get an xy ordered pair. All the ones that we've worked so far with elimination have an XY ordered pair, but I also could get, instead of crossing, they could be parallel, in which case there was no solution, or they could be the same line, in which case there was infinitely many solutions, okay? So this tells me because there's no variable to solve for anymore, it is not going to be this kind of system. It's one of these other two special ones. So what we do is we ask ourselves, 0 equals 23. Is that ever going to be true? Is there anything that x and y could be that would ever make 0 equal 23? And the answer is no. That is a false statement. No matter what, it's always going to be false. So we would say that this has no solution. And remember, the quick way to write no solution is 0 with a slash through it. Okay? And then finally, number 4. Okay, this one's got a little bit more work to it. Okay, first thing we want to do is get both equations in standard form. Okay, this will be -8x minus 2y when I move it to the other side equals -2, and positive 4x plus y equals 1. Okay, now I'm going to have to multiply through. I'm going to multiply this entire bottom equation by 2. Okay, so the top one is -8x minus 2y equals -2. Now the bottom will be 8x plus 2y equals 2. Okay, add these two equations together. That makes 0, that makes 0, so I have nothing but 0, and it turns out this also makes 0. Okay, so again, no variable, special case. So look at the remaining statement. That will always be true. There are lots and lots of things that I could plug in for x and y that will make 0 equal 0. So this equation, this system of equations, has infinitely many solutions. Okay, so to wrap this up, if you're solving a system of equations and all the variables get eliminated, if the final statement is true, then the system has infinitely many solutions. If the final statement is false, then the system has no solution.